Hello, Sloohers, and welcome to Slooh's Practical Astronomy series with me, Paul Cox, where we can learn to explore space together and get the most out of our Slooh memberships. You know, I say that every week, but, it's really genuine. I'm as much a Slooh member as everybody else here, and I use the telescopes to follow my own interests and stuff like that, so count me as one of you anyway. And I know a lot of you do because you email me all the time, which is always nice. So you can always drop me a line at paul@slooh.com. Always great to hear from you. And actually, I'll come to it a little bit later. But if you ever spot anything weird with the telescopes, never assume that we know. So always please report that. You can email either me at paul@slooh.com or support@slooh.com. Anyway, listen, if you are somewhere on the Slooh website, you know what's coming, regular listeners. We're going to fend off those antisocial people who don't want to be with us tonight for the next 45 minutes. Do you reckon we can do 45 minutes? When have I ever done 45 minutes? Anyway, if you are on the website and you're suddenly hearing the sounds of a reasonably stressed Englishman over the airwaves, then head over to the Situation Room, and you can head over there by going to livecast and up to the Space Situation Room. Just mute that and press the play button. There you go. You can hear me. That's always good. Let's do that little infinity thing that we always like. Anyway, hop over there and you can watch the show, because I will be screen sharing because we're going to be doing some interesting stuff. Or if you're just elsewhere on the website and you don't want to listen to me, then you can just go up to this little audio bug at the top and you can just press the mute button. I dare you. I dare you. Anyway, Helen is back. Helen Avery, Slooh storyteller. She's back tonight with her constellation stories now. It's been a bit of a hectic week, so I have to apologise. But we will hop over and we'll see what Helen is up to tonight, because I actually haven't had a chance to look. Corona Borealis, the Northern Crown, also seen as the broken ring of stars. It's a lovely constellation, this one, to look at in the night sky. Oh, I did actually. Come to think of it, I saw somebody wrote about it the other day in the discussion boards, and it was the first time they'd seen this particular constellation. They're new to astronomy, and they thought it was absolutely lovely. And it is. It's a beautiful, beautiful constellation. We'll maybe have a look at it in the planetarium software. But anyway, that's what Helen is doing tonight in 2 hours' time. That is 9 p.m. Eastern, 0100 UTC. So hop over to discussions. So you hop over to community and up to featured threads. And here you can see Helen's post here. So if you've got any questions for her in there, you can ask them in here. Actually, let's just take a quick look, see who it was who'd spotted this. John P, yeah, new apprentice member. Hello, John, welcome to Slooh. Nice picture of your cat. What is your cat's name? Corona Borealis, by the sounds of it. Oh, this is what caught my eye on this one. The Chinese translation means coiled thong. I'm sure that's not the kind of thong that I'm thinking of, but anyway, that's what stuck in my mind. Anyway, welcome John P and any other new members that we've got. So I'll be flicking through these screens. I kind of do this to really show new members where to find all of this stuff. So we can hop back here, and don't forget, if you've got questions for me, hop over to the Practical Astronomy May 27th post, and we've already got a couple of questions that we're going to deal with. We're going to deal with these first up, actually, in the show, just in case we run out of time, because you know what I'm like. But anyway, this tells you what we're actually getting up to tonight, and exciting one. This is something I've been wanting to do for a very, very long time. And it's to, well, actually, there are two aspects of this. The first one is collecting lunar phase images over a period to capture an entire lunar cycle, to make a montage. But once you've done that, there are other things that you can do with it as well. And one of them is to illustrate this phenomena that you may have heard of called lunar libration. And it's basically the moon rocking and rolling. It's wobbling. So I'm not a great fan of rock and roll. But, fan of rock, but not rock and roll. Anyway, we are going to be looking at this phenomena, and we're going to be doing this in practical astronomy. So we're going to be doing it with our images that we've been collecting, and we're going to see whether or not we can spot this phenomena of lunar libration. And also, still on the theme of moons, we are going to take a very quick look, just an introduction tonight, for the How Many Moons in One Night challenge. So you might think, well, okay, it's fairly obvious. We can see one moon. Well, we can't always see one moon, can we, in our night sky or our daytime sky as well? Actually, sometimes you can point out to some people during the day, if the moon's up, you can point it out to them high in the sky, and it can be really, proper daylight. And some people get really surprised. They just don't know. They've never looked at it, and they don't know that you can see the moon during the day. I have looked at it in a telescope as well during the day. I've looked at planets as well. Looked at Venus, and I looked at Jupiter through a telescope, through my Meade 10-inch telescope during the day. But everything's a little bit disappointing because they're kind of washed out, by the general sky brightness. But it's still a pretty cool thing to do, to look at these things during the day. And yeah. Anyway, I am also going to be answering your questions. Yeah, so the introduction to How Many Moons in One Night is seeing how many moons in our solar system. Only 2 planets in our solar system don't have their own moons, their own natural satellites. So there's actually quite a number of moons out there, but how many can we see through Slooh's telescopes? And more importantly for this challenge, how many can we see in a single night? And I'll be explaining a little bit later why I'm introducing this challenge now rather than last month or the month before or in 3 months' time. Like most things in astronomy, these things are seasonal, just like our Messier Marathon, where we had about 3 or 4 weeks on an absolute push, where you can see all 110 of the objects in Charles Messier's catalogue of bright objects. So anyway, right, that's kind of what we're doing. By the way, I am going to follow up actually our How Many Moons in One Night challenge during our show on Tuesday. We're doing Helen and I are doing a joint show on Tuesday, same time as this actually, 7 p.m. Eastern, 2300 UTC, and we're doing a show on the full flower moon. And full moon, full moon is actually it's on Tuesday. We'll take a look in a sec. It's on Tuesday afternoon, I think. So some people say that it's full moon tomorrow night, but actually, we just not normally pick the closest time to the actual moment of full moon, and just do the closest night to that. Anyway, I'm going to be looking more at that challenge on Tuesday evening show, so make sure you stick around for that. And of course, to round out tonight's livecast, I'll be answering any of your questions posted in the discussion board. So come over to this thread and add your questions down the bottom, should you wish. Oh dear, the old network's playing up my machine. I'm doing too much on it. Do, by the way, always for my show and for Helen's show, please always just jot a little comment down there just in case if there's any problems with our audio or anything else. I'm sorry, I cut off some pictures last week that I was trying to show you. So I was talking about these wonderful moon images for the last 2 or 3 minutes of last week's show, and you couldn't see them. But anyway, do post in there if you spot any problems, because we're doing these shows solo, but we've got our new show producer, well, our returning show producer actually coming to join us on Tuesday night show, and then Laura Grosso is coming back full time to head the studio. So hopefully we'll have lots more live shows for you every week. But come on, let's do our usual, because this is actually one of the bits of the show that I like, because it's a nice relaxing time for me, because it's looking to see what everybody's up to, what you lot are up to. And you know the place I always like to start on that. It's the Slooh homepage, and it's the observation log, it's the timeline. And this is where you can show your images to the world. And let's just increase the size of that a bit so you can see it a bit better. And okay, JW's already showing tonight. Lovely, lovely globular cluster, Messier 53. And what we always ask you to do is share your best pics up on the observation log, because you're sharing it, you're showcasing it with the world, and always pop in some interesting notes about it as well. It doesn't have to be about the object, it might just be what you think about it and why you thought it was so special. But that is a look at the colour in some of these stars. That's looking like a cool night tonight. You can have my like on that. Thank you very much, Jay. Hey, look at this, folks. I noticed this morning my rank's gone up by 1, or down by 1. So it was 20 last week, down to 19 this week. So that's a measure of my activity on Slooh. And I think that's happening because I'm tending to use this, my personal account, more than some of the other accounts at Slooh that I use. Oh, look at that. Another nice one there, Jay. That is one of what I think the best globular cluster in the Northern Hemisphere. We've obviously got some far, far better ones down in the Southern Hemisphere from the Chile Observatory. But the Great Hercules Cluster, Messier 13, is just stunning. I mean, you can see the colour of all of the stars. And, you know, this is actually a really, really good object to view at the moment. And let's just take a quick peek at our planetarium software. Let's just set it so that the clock's reflecting now. Let's zoom out a bit. So there's a couple of things that you always have to do on your planetarium software. Make sure the time's correct and make sure that the location is correct. So I'm just setting up here. You can see on the screen, I'm set for the Teide Observatory, so we're okay there. So what we can see here, oh, and this is a lovely, lovely site actually that you'll be able to see from your own backyards if you've got a clear night tonight. Unfortunately, here in Connecticut, Slooh HQ, we've got a bit of cloud. It looks like it's going to rain actually. The wind keeps coming up. But the moon and Jupiter tonight are incredibly close. But it is that moon with full moon coming up on. Let's just check actually. I think it's Tuesday during the day. So let's start up this other lovely piece of software that I like. Quick Phase Pro is our software. And we'll pull this up on the screen. And it basically tells you just about everything you ever want to know about the moon. Once again, I have this set to the location. I set it to GMT, which is the same as UTC. So I always am dealing with the same time zone, UTC, when I'm using Slooh. And what we can see down here is 29th. Yep, so it's on the 29th. So that is Tuesday afternoon at 20 past 2 UTC, so 14:20 UTC. Is full moon. So, you know, look at this. So tonight, right now, it's a waxing gibbous moon. It's 98% phase, which means that we're seeing 97% of the entire face of the moon there. And that's quite relevant, actually, isn't it, for what we're going to be talking about a little bit later, because, as you know, the moon always displays the same side to Earth. We'll talk about why that is a little bit later on, but so really we can only ever see 50% of the moon's surface. Or can we? Spoiler alert. But anyway, listen, what I was saying was, started off with Jay's image of Messier 13, that globular cluster. Now, when there's a lot of moonlight in the sky, so here we've got this 95% moon, so we can see it here. So there's the moon. Oops, it helps if you don't click on other stuff. So there's the moon. This blue line that's cutting all the way across. Oh, you can't see this. Darn, why can't you see that? Gosh, look at that. Oh, all that time I was talking to you and no one said, right, I want to show you Quick Phase Pro again. Sorry about that, folks. Can't get the staff. That's the problem. You just can't get the staff, right? There's that little program I was talking about, Quick Phase Pro. So in here, I've set the location. I've set my time to GMT, and this is where I was getting that information. So here we go. That's the time of the next full moon, and it shows the next quarter and stuff like that. And it's showing us here that it's a 97% phase waxing gibbous moon, and it's got other nice things in here as well. So calendar, and this is pertinent because of Jay's Messier 13 globular cluster. The globular cluster is very, very bright for deep sky objects, so that's an object, a nebula, or a galaxy, or a star cluster in the sky, not a planet or star, basically. They're really quite bright objects, and that means that they don't suffer from a moonlit sky, whereas other objects, faint fuzzy objects, are badly affected because the moonlight basically adds this sky background and it lights up the sky. I mean, let's take a look. Let's take a look at the telescope pages. So up to telescopes, down to one of the observatories. Let's go to Canary 1. I want to see what's in the telescope. Oh, look, that's interesting. I was about to say I don't want to see what's in the telescope, but look at that line down here. So let's get rid of the circular portal. And ooh, that's an interesting one. That looks like, oh, what is that? It looks like a satellite to me. But we need to check what William Yeager is looking at here in HDF. Anybody who can look that up, do post it to the thread in discussions so that we can share it with everybody else. But let's just take a look at our all sky at the moment. And look at this. I mean, it looks like it's daylight, for goodness sake. The sky is blue. Now, don't forget, we're imaging objects against that incredibly bright background sky. And if the sky has that level of brightness, then it's like imaging at twilight. And you can see in this image, actually, this is a good example. This is a lot noisier. So when we say noise, it's all the kind of graininess in the background. And you won't find that on a moonless night. So the sky background, really has a bad effect. Let's just try and find a good example. Look at this. This is a superb example. Look. So here we go. This is Messier 84. It's a lenticular galaxy, which is basically this amorphous galaxy here, but there's other galaxies here as well. There's one up here, there's one over here, and there's one over here. Some of the galaxies in the constellation of Virgo. But look at this image. It's kind of got this strange green hue over it. It's blue around the outside. Why? Why is that? Is the telescope broken? No, it's not. It's because the sky background is so light. And quite often, you will see with moonlight either a green or bluish hue to the background images. Now, the telescope which is affected worse by this, and by the way, this is why, this is really what I'm getting at here. You could see from that image of Jay's, and let's just take a look where M13 was, that great, the great Hercules cluster in relationship to the moon. So you can see here, it's just a hop over from the moon. So the sky is really quite bright. Let's, if we hop over back to our all sky view, we can see where that is. So it's up here, it's just here where I'm pointing in the all sky camera view. So the sky is incredibly bright, but it wasn't affected, was it? In the same way as that galaxy photo is affected. Let's just take a quick look at the ultra wide field. oh, this is my moon mission. Ooh, and actually we need to, oh, pretty. I'm so pleased. I've nearly got a full set. Now then, it's my mission, so the images from this mission will automatically go into my pics, but you lot can snap this, if you like, just by pressing the camera button. Oh my, what a lovely image. Oh, I'm so pleased I've got that. I'd actually forgotten I had set that up. I just wanted to go over, while we're talking about the sky brightness thing, and I hadn't planned to talk about this, so do excuse me for the slight diversion. But I think it's a really important thing to know, especially if you're new to Slooh. So this telescope, the Canary Deep Sky Telescope, unlike the other telescopes, it doesn't use filters, it doesn't use a grayscale CCD. This uses what's called a single shot color CCD camera. So it's still an astronomical CCD camera. It's still cooled down to minus 40 degrees C or something like that. But you can see that this camera is so badly affected by moonlight. We even considered, taking this particular telescope, Canary 3 Deep Sky, offline during these kind of lunar phases. But there are still some interesting things that you can do with this telescope during these lunar phases. But you can see here just how affected it is by this huge color hue. Let's just take a quick look at Canary 4, see what's popping in here. Oh, this is a close-up view of the moon by this guy called Paul Cox. That's the member who's doing this. Waxing gibbous moon, there it is. Pretty good one. I've got some work to do on the Canary 4 telescope. I'll be going over fairly shortly to the Canary Islands Observatory to do our pre-summer maintenance work, fixing that pesky CCD camera on Canary 2, and also doing a little bit of work on Canary 4 to improve it a bit. But anyway, so anyway, what I was saying there is do what Jay's done here. So for Jay's missions tonight, he has picked some fairly bright objects, and they are not as badly affected by moonlit skies as other types of missions. So there you go, waxing gibbous moon, the planets, globular clusters. Those are the objects to go for when the moon is up and you can't avoid it. Now, I hope you saw this today. This is one of the captures I shared on the observation log today. I think Ivan shared one there as well. But this, I hope you caught this today. This was the Slooh Canary 5 solar telescope, giving us this absolutely epic view this morning. Let's just get this full size so we can see that. So I don't know if you noticed what I did there, but if you want to see our image pop-up, when you press download, the image pop-up that comes up is limited to this particular size. Well, if you want to see it and be able to zoom in before you kind of download it or anything like that, what I usually do is I just, using Chrome, right-click, open in a new tab, and then you can go off and see it, and then you can use your zoom control. But look at this dense knot of plasma. Now, when we see this kind of thing on the sun's limb, which is the sun's edge like this, it's called a prominence. When we see it on the face of the sun, we call it a filament, but it's exactly the same thing. So anyway, that was what I was showing today. Let's just take a quick look. There's an interesting little one in discussion boards today as well about back buttons and stuff like that. And you'll find that in a number of places where you can go on Slooh, if you use the browser back button, it doesn't really take you to where you left off, which can be a bit of annoyance. And this is an outstanding item that we've got from our last bit of development. And we are picking it up. In fact, after it was written about in the discussion boards today. Oh, look, I didn't notice that today. Another prominence down here. I did talk about this to Slooh's Chief Technology Officer, Ed Kalin, today, and it's actually a bugbear of his as well. So we're all with you on that, and we will get that one fixed, as well as a whole stack of other things that we've got lined up as well. So anyway, that was the other solar activity that was going on today that we were looking at. And you can see here, we've got this lovely line of active regions. So the active regions are the bright ones. And the sun is rotating, kind of this left side is rotating towards us, the right side is rotating away from us. So these objects we'll actually see cross the face of the sun this week. So up here on the 3 o'clock position, there's huge active region that we've been watching all week. Then another active region here, another one up here. But this one is looking incredibly active and angry. When you see bright areas like that, they're called plages. Now, this kind of is starting to look, it's getting quite a lot of structure in it. You can see all these curved lines. That's how all of the plasma is being sculpted by those magnetic field lines where they're breaking through the sun's photosphere. And we can watch that this week. And this is now starting to point towards Earth. So these things can let out quite a lot of energy. So there's a good possibility we might see some solar storms again this week. But anyway, have a look through there because I thought that was all quite interesting. We've got some interesting stuff in there. But let's take a quick hop over to community and see what people have been talking about over there. Well, don't forget, you've got Helen later on. And she's also asking actually for questions about anything you'd like to know about moon law for our full flower moon show on Friday. There's the post about the back button. Lots of members agreeing with that one, so we got straight onto that, of course. Strange goings on in Chile last night. Thank you very much. Now this is what I wanted to point out. So this is long-time member Tony Evans pointing out a problem that he spotted with the Chile missions last night. A certain batch of them weren't producing as many images as were normal. And so okay, that's great. And it gave me the opportunity because I hadn't actually spotted it. And that's what I was saying earlier about reporting problems. Please don't assume that we are aware of all problems. So I fortunately saw it here, but it's best to kind of report those things to support@slooh.com because that's monitored all the time. But it actually turned out to be a problem with one of the processing options, which meant that all of the missions that were using the faint nebula processing preset weren't completing. But because I saw Tony's report, I was able to fix the problem. So please always point us to any problems that you do spot, just in case we're not aware of them. All right. Begins. Yeah, there's not a lot been going on this week. Jay's there. So Jay, actually do take a look at some of Jay's planetary images, his Saturn ones and the Jupiter ones that he was doing last week. Absolutely gorgeous. Look at that. So he's done a little bit of processing on that, changed the color balance a bit, which improves it greatly. And of course, that is one of the planets whose moons we can see in our challenge a little bit later on. A few other things in there as well, but I think it's that was a nice one because I've been working actually on some new options, some new processing, real-time processing recipes for planetary nebula. But this is one that David M has been going over his some of his old data, and he's reprocessed this one. And this is one of my favorite planetary nebulae. In fact, I think it is my favorite planetary nebula. It's the Eskimo Nebula, and it's named for that. If you turn it upside down, it looks more like it, but it looks kind of like an Eskimo's face with the big furry parka hood going around it. But anyway, so that's what's been going on. Now then, lunar libration. Let's get on to the main topic at hand. So when you first kind of start out in astronomy, one of the early things that a lot of people learn is that the moon is what's called tidally locked. Now let's just hop over to my pics because so going over to my pictures and we'll go over to photo roll actually. Sorry, a bit slow because my machine's doing lots of things. And I'm going to filter by solar system. And also, I only want to see my Canary 2 images because these are the ones that I've been taking recently. So here you go. So there's some of my recent moon missions, my recent moon images. But when you first start out, one of the first things that, or an early thing that you learn, is that the moon's what's called tidally locked to the Earth. And there's another term for that as well. It's called synchronous rotation. And it basically means that the moon's rotation on its axis, its spin, takes the same amount of time as it takes for the moon to orbit Earth. Now, the moon rotates on its axis, every 27.32 days? Correct me in discussions if I'm wrong. Which is the same period of time that it takes to orbit the Earth. There's a couple of funny little anomalies in there that we won't go into at the moment, but that's basically what it means. So as it's spinning on its orbit, it spins in the same duration of time as it takes to orbit the Earth. Now, an extreme example of this tidal locking actually can be seen with Pluto and its moon Charon. And I think it is pronounced Charon. I always used to think Charon, but I think Bob corrected me once. Bob Berman corrected me once, said it's Charon. And Charon is such a large moon compared to Pluto. Our moon, actually, in comparison to its parent planet, the Earth, is incredibly large. Most moons are a lot smaller than their host planet. But Pluto's moon, Charon, is an even greater example of this. It's really very large in comparison to Pluto itself, and they're tidally locked together. Now, that means that Pluto only sees one face of Charon and vice versa. So imagine you're a future Pluto explorer. My word, I don't have many regrets in life, but the one small regret is I just feel like I'm born about 50 years too early. I'm not going to get the chance to go into space, which certainly my grandchildren will. But anyway, imagine that you are this future Pluto explorer. You'd witness this really bizarre phenomenon where the moon Charon would always be in the same place in Pluto's sky, which means that if you're actually on the other side of Pluto, you'd never see the moon Charon at all because they're tidally locked together. Now, back to our own moon. It's this synchronous rotation that results in the moon always displaying the same side to us, the side referred to as the near side. Now, the other side, the side that we can't see from Earth, is often incorrectly called the dark side of the moon. I was listening to that album last night, actually, revisiting that Dark Side of the Moon, Pink Floyd, very good. But anyway, it's a wrong term. That face of the moon, the far side of the moon, receives just as much sunlight as the side facing Earth during its orbit. But because the moon is tidally locked, we only ever see one face. We don't see that far side when it's illuminated. So if the moon is always only presenting one side of itself to Earth, we only get to see 50% of the moon's surface. Is that right? Well, actually, we see far more than that. From Earth, we see 59% of the moon's surface over a period of time. What? I hear you ask. Has Slooh got telescopes that can see around corners or bend light? Well, I am working on those, but until then, unfortunately not. We can see this 59% of the moon's surface over a period of time because of this phenomena called lunar libration. So what is it? Well, I'm going to go into more detail about some of these effects because I've got some great graphics lined up that Laura in the studio is going to bring up for us on Tuesday's show. But first of all, I guess, when we're talking about anything to do with astronomy, where does the name come from? Where does that term libration come from? And does it give us any clues about the phenomena itself? Now, like many astronomical terms, the word comes from Latin. And in this case, it means balancing scale. And I was really, I kind of enjoyed learning this little bit today, that's where this term libration comes from. Because if you can remember, a couple of weeks ago on Helen Avery's show about the constellation of, and I'm going to say it how I've always said it to start off with, Libra, and I think that's how most people pronounce the constellation of Libra. Helen said during her live cast, actually, when she'd been doing her research for the show, it turns out it should be pronounced Libra. And I kind of scratched my head at the time. It didn't surprise me because there's always something in astronomy to catch you out as far as pronunciation is concerned. So I didn't think kind of twice about it. I just thought it was another example of that. And, I think Helen said, she's going to have difficulty. And I thought the same thing when she said it. I'll have difficulty now thinking about, Libra as Libra. But when we think about this Latin root term that gives us also this term libration, that's how we're saying Libra. So libration. So anyway, it refers to the way a set of scales tips up and down on alternating sides. So that's the root Latin of this word, libration. Now, there are three causes of lunar libration, and this is what I'm going to go into more detail about Tuesday. But one of them is called libration in latitude, libration in longitude, and then we have observational libration, which has a far less impact. And we're not going to go into it now because this is practical astronomy. We'll do a bit of kind of learning later, but we're going to be looking at this in our images. So picture paints 1,000 words. There are other contributors as well. The observer's position on Earth also plays a role in the amount of libration that you see, but it's absolutely tiny in comparison to those first two, the libration in latitude and libration in longitude. And from the Canary Islands in the Northern Hemisphere, we actually see, and until I really started looking at this over the last couple of weeks, I hadn't really twigged. And, when you do look it up, it makes far more sense. From the Canary Islands in the Northern Hemisphere, we see more of the moon's northern surface, whereas from the Chile Observatory in the Southern Hemisphere, we see more of the moon's southern surface. So actually, that's something I'm going to try. I hadn't thought of that until I just said that. It would be quite a cool exercise, wouldn't it, to be comparing images from Chile and the Canary Islands of the moon, maybe a close-up, maybe if it's north and south, the top and bottom of it, to see just how much of a difference that change in latitude in the observer's position actually makes. Just how much more of the northern hemisphere of the moon can we see from the northern hemisphere versus from Chile? So anyway, what else have we got here? So, actually, that was the other little nugget of information I found. There's another interesting, once again, little contributor to this libration, one that I didn't know until yesterday, in fact. We see more of the moon's eastern surface at moonrise and a little more of the moon's western surface at moonset. And once again, it makes absolute sense when you start thinking about the geometry of it, of you as the observer looking at the moon. But I simply hadn't considered it before. So anyway, taken together, all of these contributors to libration mean that although at any one moment we can only see 50% of the moon's surface like we can in this image up on the screen, over time we get to see 59% of its surface. And as I say, we're going to delve into libration a little more on Tuesday's full flower moon show, but for now, let's see this in action. So, excuse me, just need to readjust the equipment, take a little sip of water, take a deep breath. Let's get ready for some practical astronomy. So the reason why I wanted to put up this image here is because I need it. I haven't got the image tonight, so I'm just going to save this image. I'm going to save it in here. I've just actually been changing the name of these so that they appear in date and time order. There was a nice little discussion actually last week about file naming in Slooh, and one of the things that I have asked the development team to review is to do just what I've done here, which is putting the date and time first, not the object name or the coordinates first. And that means you can have any folder of images, just like I've got here, and you automatically, without having to sort them by date, because you may have actually edited them so the date's going to be slightly different. I've got a warrant image in there, don't need that one. We can see here that having that as the first facet of our file name means that they're automatically in order. So anyway, that's something that we're going to look at. But listen, this is what I've been doing. So if we just go back to my pictures, so don't forget what I've done on here is I filtered my solar system object, and I filtered on the Canary 2 images because for this exercise we want to use images from the same telescope. So here you can see a bundle from tonight. We missed a night, unfortunately, on the 25th. So what have we got here? That is the 26th. That is the 26th. And then we hop back to the 24th. And you can see here quite a marked change in the phase of the moon because we missed a day. But let's go back even further. And here we've got fourth quarter. So all I've done here was I set up a mission every night to the moon using the Canary 2 ultra wide field telescope. And you can see here, this is the beginning of this exercise. So that was another one that I took back in March. So this is the beginning of this exercise. Now, ideally, I would have done it a little bit earlier. In fact, no, I have actually got some images from another account 2 days earlier than this, right? So what I've got here is this nice little group of images in here. It's, yeah, that'll have to do for now. And you can see this is the first one. So make sure this is on the screen that you can see, always helps. So there's our first image. It's a waxing crescent moon. That was a few days old. Then we're hopping forward. So a waxing crescent until it gets to its first quarter. Still a waxing crescent. So you can see there's this huge, you know, from new all the way through to first quarter. They're all waxing crescent moons. Waxing just means that it's getting bigger and bigger. So here we go, and there's our first quarter moon. And then we're into waxing gibbous. So the waxing just means it's growing still versus waning, which happens after full moon. So after Tuesday, it's going to be a waning gibbous moon. Then it will be last quarter moon. Then it will be a waning crescent moon. But this one is a waxing gibbous, and gibbous just means that it's past first quarter. And here you can see the next one there, that's waxing gibbous as well. And this was last night, and then there's my shot from tonight. All right, so there are all of my images. So I don't know, if we speed through these quick enough, can we see any kind of wobble, any kind of rocking and rolling on the moon? Not really. It's pretty difficult to see, isn't it? Because of, you know, the change in phase and the fact that the images are not lined up as well. doesn't help us. So, like so many exercises in astronomy, that's exactly what we're going to do first. We're going to align these images. Now, frankly, you could straight away, stick these into your favorite editor. And it doesn't matter what it is. It could be GIMP, it could be any of the free ones, or if you've got Photoshop, anything like that. You could take one of the images, or you could start something totally new. You could make its canvas size, I don't know, let's try something absolutely ridiculously big. And what you could do here is center, no. So I want this to be in 0. So all I'm doing here is I'm just increasing the canvas, the size of the image. And there you can see the original image down there. So I basically just increase the size of my paper, if you like. So there's one image, and then I could take this, and I could either take an extract of this image, and I could just do Control-C. I could bring that into my new larger image, and I could carry on doing this over the course of a month, and I could make a really cool lunar phase montage. So just pull them all in, and of course you can tidy it up, you can then annotate them and stuff like that. But the trick, of course, is to be lucky enough to capture an entire month using preferably the same telescope. So anyway, you could, this is another with these lunar phases, which is just quite a fun thing to do. But what we need to do tonight is we need to align them. So we're going to pull these in to Maxim. Now you could, by the way, you could start aligning all of your images manually. So we could paste them into another one, and I just need to change the transparency on this so I can move it over, and you could align them like this. But look, that's interesting, isn't it? I can't align these features. Isn't it a good idea that I showed you this? Because it actually is showing us that something is wrong. This is consecutive images from the same telescope, and the telescope hasn't changed overnight. But look, these features, if I line up, let's say that little crater right at the top of the moon, or if I line up one of the moons, it's not lined up down the bottom. And you can see this kind of strange swirly effect going on here. Actually, it looks quite cool, doesn't it? It kind of makes it really look 3D and stuff like that. But look, we haven't even got Copernicus and some of these other large craters and features. They just don't line up. So what's going on? Because the telescope isn't changing. The telescope is fixed. North is always up. And when we say north, that's north in the sky. So north is up, east is left on all Slooh images. So the telescope hasn't changed. So we know that something else is going on. I'm so glad I did that because it's such a good demonstration of this. But anyway, what we need to do to explore this even further is actually, I just need to do one little thing, if you'll excuse me. I'm going to try and stick to time as much as we can tonight. Talk amongst yourselves. Won't be long. A couple of minutes. Oh, I had already done it. It's fine. We're not going to be cut off, but we want to leave you time to hop off and get a cup of tea or something before Helen's show. Helen's show starts in 1 hour and 10 minutes, so plenty of reason to stick around here at Slooh. Anyway, the first thing we want to do, like so many exercises in astronomical image processing or looking at phenomena like this, is about aligning our images. And it doesn't matter whether you're doing that for some astrophotography, it doesn't matter whether you're doing a bit of time-lapse, it doesn't matter if you're doing some capturing of an asteroid for the Near-Earth Asteroid Program. Or you might be doing the Discover Pluto challenge. where you try and spot this tiny, tiny little star-like dwarf planet moving against the background stars to replicate Clyde Tombaugh's discovery of it back in the early 20th century. But anyway, there are a number of ways that you can do this. So you could do this in your free layer-based program, and you'd have to go through and you'd have to do this individually on each one and line them up. But I'm going to use this particular software, Maxim, and I'm going to use the alignment routine. Now, if I just try to align all of these images, so I'm just going to add all of my lunar images. By the way, I'm going to carry on collecting these lunar images for the remainder of the month, because I really want to finish this exercise off. If you can see the options here, how the alignment options. If I use planetary and stuff like that, it's just not going to work with the moon because the phase changes so much. The software can only align something if it's the same in every image, and of course it's not. So, but this one does have one little useful utility, which is called overlay. And if I then just flick through to the next image, you can see here that actually I'm just going to make this full screen so I can see it a bit better and you can see it a bit better. Now I have already, people in the UK will know a program called Blue Peter, which was a children's program, and they used to do these they used to make things every week, and they always used to reach under their desk to say, and here's one I've made already. In the same way that actually I have already aligned some of these images, but you could see that some of the images I only downloaded from tonight's mission, so I haven't done that yet, but you can see here, and it will be a bit more obvious. There's one that I haven't done. So what I can do is I can nudge. So the green image is the latest image, or one of the ones that I haven't aligned. The purple is my main background image, and I'm just trying, because I know that the craters don't line up, what I'm trying to do here is I'm aligning so that we don't have any purple or any green fringe around the lunar edge. All right, because if I know that, if I've got the edge lined up, it's just about doing it. Never going to be exact on this one, because the moon, of course, is changing size as well. But that'll do us for this one. Then moving to my next image. And all this is doing is I'm just nudging it. You can change this value to more than 1 pixel if you want. I do wish they'd do a bit of a drag and drop on this as well. It would make it so much easier, especially when I make when I do time lapses of lunar eclipses and solar eclipses. So you can see here, right, that the moon, the green one, so the current image is our image from, when is that? I think that's the 23rd, right? You can see that it's smaller than our image, our primary image, the purple one, in the background. And that's because the moon's orbit is elliptical. So sometimes it's further away from Earth, so it looks smaller, its apparent size is smaller. Sometimes it's closer to Earth, and it looks larger. When those coincide with a full moon, that's what gives us a supermoon. So if it's really close to us, within 3 days or within a day and a half or something, of its closest point to Earth, when it's a full moon, then that's when we call it a supermoon. And equally, when it's a long way away, when it's furthest away from us in that elliptical orbit at the time of its full moon, that's called a micro or mini moon. But that's what's accounting for that change in size. So I guess I really should be aligning it like that. So I'm going to go back to my previous image, and I'm going to do the same on that one, because then, actually I might need to do this. No, the others are okay. So there's that. We can adjust this if we need to. I think I'm going to go down and just 1 over on that one. Let's go to the next image. Oh, this one needs a lot of alignment. So let's change this. Let's boost this up to 10 to start off with. So once again, the purple image in the background is my original image the image of the first day of this entire sequence. So that's what I'm using to align all of my other images up. So the green one is the one that I'm currently aligning. I think we're close enough there where we can knock that back down to 1. And once again, I'm just going to, gosh, I hadn't realized just how much difference there was in the size of the moon. You know, we know that this happens, but look at that. You know, over the course of, what's that? Over the course of 6 days, that's how much the moon has shrunk as it's moved further away from us. Anyway, let's do the next image. We're nearly there. Oh dear, I thought I'd done more of these actually. Once again, you just can't get the staff. So I think this is tonight's image that we're looking at. No, this is last night's image. Look how much smaller it is. So don't forget, this is the same telescope. Just look how much it shrunk as it's got further and further away from us as the month has drawn on. So this is actually going to be quite a small new moon. So I hadn't kind of accounted for this. So it's going to be quite interesting, isn't it, to see how this looks in our animation, especially when we do the animation at the end of the month. Let's go to our, right, this is our last image that we've got to do. This one is from tonight. So let's just nudge it over. And maybe what we'll do is, if we're lucky and we manage to capture a full month, we'll come back to this exercise with the very last waning crescent that we see. And we'll finish this exercise off and finesse things like this. But look at that. Just look at how much the apparent size of the moon has changed over the month. Anyway, listen, there you go. So I've done all of my images. They're all lined up. Thank you very much. All I've got to say is okay. And it's basically just now aligned all of these images so we can see them. They're all at a different size, so you can't really see them. There's got to be a better way of me showing you that. Cascade. No, wasn't a better way of doing it. So anyway, listen, what we're going to do here is we could use our, I'm just going to save these, by the way. So I'm just going to go File, Save All. Thank you very much. And there it goes. So if we go back to our lovely folder, look, you can see that they're all aligned properly now. So if we pull this up now, if we flick through them now, they should all be aligned. Ooh, look at that. Oh, and look at that. Were we expecting that? So there's one frame there that I could have aligned a little bit better. But look, there's our start point. And I'm going to put my cursor on in the middle of this particular mare, this particular sea. Is that tranquility? I don't know. And we're going to hop forward. Actually, let's choose a smaller, more defined object. So let's go on this crater here. So hopefully you can see my cursor. And let's hop forward and see where that crater moves to overnight. Look at that. It's gone way up there. So already, just over the course of one night, we're seeing this rocking and rolling of the moon called libration. So up goes that crater. So up it goes, then it goes up again, then it goes up again. I need to crisp some of these images up. Then we go, look, let's do it on the sea actually, because it will probably be easier to see on the sea. So there we are, centered on that sea, the mare, already out of our cursor. Look how much it's rocked up. And don't forget, you know, the moon's or the celestial north is directly up in this image. And the telescope's exactly the same from night to night. So everything that we're seeing here is an effect of the moon's real relationship geometrically with the Earth. It is really rocking. It's really wobbling as we're seeing it. So it's kind of stopped there though, didn't it? Look, the difference between two of those, and that's one of the ones I need to maybe align a bit better. But if we go from there and there, we see quite a lot of movement, but then actually it stopped rocking. But let's go to the next one. It starts heading back. So this is rocking and rolling. It's wobbling forward, it's wobbling back. And that's what we're seeing. That is lunar libration in reality, in our telescopes. So I wish we could do the same thing and show the flat earthers, you know, look, there's a picture. Mind you, we do show them pictures, don't we? And they say, oh, they're fake. They're fake. The Earth's flat. But anyway, look, if you ever wanted an example of knowing that our local satellite, now imagine this rolled out to the end of the month. That would be quite cool. So anyway, what I was going to say was we can use our trusty software, can't we? Our animation shop software. And what we can do here is use the wizard. If you haven't seen this software before, it's really cool. It's free. It runs on all versions of Windows. If you're a Mac user, I'm afraid you're on your own. But press the wizard. This is the easy way of doing it. Just go through, accept most of the defaults. All of those, that's fine. How long do we want each one of these on the screen? I think we'll probably put them up for 50th of a second. 50/100ths of a second. Let's add our images. So here are the images that we've aligned. I'm going to add all of them. And they're already in order. That was the benefit of having those names like that, because they've automatically sorted in the order that we want. And you could, of course, during fuller phases, you could reduce the period of time. You wouldn't have to do this one night after another. You could actually do this, a couple of times a night, but they would change your animation rate during your animation. So here we are. And what we're doing here, of course, is we're creating an animation, which the clue is in the name of the software's name. So let's just say file, save as, and we do other work to this. Let's go there, and I'm going to accept all the defaults on this. We could reduce the size of this by going kind of grayscale, but not important for this particular exercise. So we have now created an animated GIF. Now then, let me see if I can. Don't know if Chrome. Yes, it does. So there's our little animated GIF that we've just made, right? And you could share that with the rest of the world. So what a cool exercise to do. And it's obviously not over yet. So what we started off by saying, and I think you can see it on this animation, look at some of the features on the very edge of the moon. In fact, it would be easier almost. I'm kind of holding my hand over most of it, so you don't see the phase change, but just keep an eye on one small feature near the limb of the moon. That's the edge of the moon. And you can actually see new features coming into view as the moon is rocking and rolling. And that's why we can see over the course of time, 59% of the moon's surface, not just 50%. Because as it's rocking and rolling, new features are coming into view, and then it's rolling back. It's going to start rolling back, which means that we'll lose some of the features we could see on the right, but we're going to start seeing more of the objects and features on the left. Now, I had not done this ever before, so I'm really quite excited by the first results of this, because it's something I've always wanted to do. So basically, you're indulging me tonight. This wasn't for you lot at all. This was just for me, so that I could do this exercise that I wanted to do for a long time. But of course, this is also building up to the other exercise I want to do, which is to create a lunar phase montage. You know, the kind of thing. And in fact, I've got I was looking up some lovely, lovely examples during for the show on Wednesday, and actually that's Mercury and Venus at the top, but we've got the moon down the bottom. I think I've got another one here which is about the moon. I want to make a diagram like this, but with real Slooh images, so that when we come on to one of our moon shows, we haven't got to pull up something from Wikipedia. We can actually pull something up and say, look, those are all of the phases, of the moon as we've seen through the telescopes. And what this diagram is showing, by the way, just as explanation of it, if it doesn't make sense straight away, is you've got the sun on the left-hand side. We all know that it has big spiky things coming off it and a great big face, a great big smiley face. It's a nice sun until it sends a coronal mass ejection towards Earth and wipes us all out in a global apocalypse. But other than that, it is quite a friendly, life-giving object. But what we can see here is the outer ring is showing us how the moon looks from Earth. In fact, this one I don't think is doing that very well, but that's what it should be. So the first one is just showing how it's illuminated. The inside circle is showing it how it's always illuminated. You can see actually this is kind of reverse, this diagram. So the bit that's in dark is actually the sunlit bit. So this bit is showing in its orbit around the Earth. That's always the sunlit side facing the Earth. And then the little object out here is how it looks from Earth. And that's what I want to generate with real Slooh images. So a couple of exercises here. Now, if you want to join me in this, please do, because no doubt I will run out of time and not be able to finish this until probably, looking at my diary now, probably 2020, maybe 2021. So, if you guys want to take some inspiration from what we've done tonight and do one of these yourself, then we're coming up to an ideal period of time to do it. We're coming up to summer in the Canary Islands, which means that we will be online virtually every single night. The weather's always superb there during the summer months. Of course, the summer night skies are short, which is unfortunate, but we will always see the moon every night, which means we're going to be able to produce some of these particular kind of graphics. And, well, they're not graphics, are they? Real images that are showing these lunar phenomena, both the phase and also the rocking and rolling of the moon. So anyway, I'm really pleased about that, that it's kind of worked out in the way that I had hoped. Now, how many moons in one night? I want to talk about that very briefly. We'll wind up soon. But really the first thing and only thing I wanted to talk about tonight is why now? Why am I raising this challenge to you at the moment? So the challenge is, how many moons of our solar system can you capture in Slooh's telescope in a single night? Well, this has changed recently because there's some great work by a few members. I think it was Darryl or Jay, one of the two. It was Jay, wasn't it? Managed to capture Mars's moon, Deimos. And I don't think we've ever done that before. In fact, Maynard Pittendray, long-time member, 2004, I think Maynard goes back to. He tried to do this on several occasions and had never managed to do it. But there you go. So Jay has proven that with Slooh's telescopes, we can capture one of Mars's moons. We can't capture Phobos by the looks of it because it's too close. But how many other moons can we see? Well, I started off the show by saying only 2 planets in our solar system don't have moons. That's Venus and Mercury. They don't have moons of their own. Obviously, Earth's got a moon. Well, we've seen that quite nicely tonight. Moving out, we've got Mars with Phobos and Deimos, and we know that we can see Deimos. So we'll take a look. In fact, you can see so I've got the sky chart. Let's set it for the current computer clock, which it is, and we can see here that Mars is just rising. Okay, so that's good. Mars is going to be visible for us. That's good, number 1. So maybe we can see Deimos. Well, Jupiter's the next planet out. Gas giant Jupiter, my favorite. And we can see very clearly there full moons, and you don't have to try very hard to see those. You can see those in any of the ultra wide field shots with either the Chile 1 telescope or the Canary 2 ultra wide field telescope. And you can see the 4 of them, as long as they're not transiting or being occulted or eclipsed by Jupiter. So when they're being occulted, they're behind the planet. When they're being eclipsed, they fall into the shadow of the planet, but it's very difficult to see them when they're transiting in front of the planet, but often we can see their shadow. But we've got the 4 of them anyway, and they're the 4 that Galileo spotted in 1610. So we've got Io, we've got Europa, we've got Ganymede, and we've got Callisto. And those are his string of pearls, is how he described them the first time he saw those moons stretched out on either side of the gas giant Jupiter. And a very important finding it was too, because suddenly, over a few nights, he determined, in fact, I think it was over 10 nights in all, and there's a lovely sketch by him. He determined that these were not background stars. They were obviously moving with Jupiter, but because of his observations of one night to the next, he could tell that they were orbiting Jupiter. So suddenly, the Earth is not the center of the heavens, because we suddenly see 4 objects orbiting another planet, Jupiter. So we can see those 4. How about Saturn? Well, we've got Titan. Titan there is, I would say, relatively easy to spot in the Slooh telescopes, but can we also capture Enceladus, Rhea, Mimas, and any of the others? Well, that's the challenge. Going out further still into our solar system, we reach the planet Uranus, the ice giant Uranus. And surprisingly, even though it's so distant from us, in our telescopes, we get to see Oberon, Titania, Umbriel, Ariel, and Miranda. Now, we can't always see all of those, but see how many you can spot in one night. And then further out still, we've got Neptune. And with Neptune, we often see its largest moon, Triton. So we've got one more, which isn't really a planet. It's a dwarf planet now, Pluto. And Pluto itself is difficult to spot in the Slooh telescopes. You can see it, but we certainly can't see its moon, Charon. So we've got to discount that. So anyway, going back to the beginning, Mars. Can we see Mars at the moment in the night sky? Yes, we can. It's just rising now. In fact, it's going to be at opposition in a couple of months' time. That's when it's visible all night long. Okay, let's go out further still. Where's Jupiter at the moment? Can we see Jupiter? Well, it helps if you can spell Jupiter, of course, when you're searching for it in your planetarium software. But there it is, really well placed. So we can see this from the very start of missions for about 4 or 5 hours, something like that. So we'll certainly be able to see the 4 moons of Jupiter. Okay, next planet out, Saturn. Can we see Saturn? Yes, there it is. It's between Jupiter and it's between Mars. Okay, so far so good. We can see 3 of the planets whose moons we want to capture. How about Uranus? Okay, so Uranus, my software is telling me here that its altitude right at the moment is minus 44 degrees altitude. So it's 44 degrees below the horizon. So let's switch off the computer clock so it's not in real time. And let's step forward an hour and keep an eye on that altitude figure. So step forward an hour at a time, pops up minus 35 degrees, minus 24 degrees, minus 12 degrees, 0 degrees. It's just rising. All right, let's go one more, because when is the end of missions at the moment? Let's just take a quick look at that. End of missions. Sorry, I've got 2 screens. Telescopes, let's go to scheduled telescopes. Go to telescopes. End of missions in the Canary Islands is 0505. So actually we were fairly close there. So look, here is Uranus. It's only 11 degrees above the horizon, but it's going to get higher and higher every night. So there we might be able to see Oberon, Titania, Umbriel, Ariel, and Miranda. That's 5 additional moons of our solar system that we might be able to see. And when I say it's going to get higher and higher every morning, if we just flick forward a day at a time now, at the same time, you can see it's just getting higher and higher. So there was that one. Let's go back to our computer clock. Let's go back to the last planet that we can see, the ice giant Neptune. That's well below the horizon as well. Let's switch the clock off, move forward. There it is above the horizon already. So we can see this for at least a couple of hours. And by the end of the night in the Canary Islands, it's at 36 degrees. So we're certainly going to be able to see Triton. So there are a whole bundle of planets that we can see at the moment. In fact, with the exception of Venus and Mercury, we can see all of the planets. We can see Mars, Jupiter, Saturn, Uranus, and Neptune in a single night. Only just, because Uranus is just coming back into our pre-dawn skies. But that's why I'm introducing this challenge to you now. Because to see as many moons of our solar system in a single night, you obviously have to be able to see their host planets, and you can do just that now. So pick up the challenge, work through it with me, hop over to the discussion boards, post your plans in there so everybody else can get involved. I'll lend a hand as well, and we'll see exactly how many of these we can do in a single night. So any member, if you want to kind of take up the challenge and maybe put a post in the discussion boards to talk about it, then please feel free to do so and lead that challenge. Otherwise, I might pick it up as well. But anyway, so that's it. I'm going to talk more about that on our Tuesday full flower moon show. But we will just take a quick look over here. I was going to do these questions earlier because we always run out of time, so I can't do them. And I've done exactly the same to you tonight. But what do we got? So that was Daryl just saying, I need a new exercise to do. And yes, David, I was throwing down the gauntlet to you. And there it is. You know what it is now. GL, Slooh Crew. It's about time, GL, isn't it, that you joined as an apprentice member? Come on, help support Slooh. Come on. It's only $5 a month. Less than that. $4.95 a month. You get to make your own reservations as well. So anyway, GL, you've been around for a long time. Are there any plans to install new equipment on the various scopes? Possible reason for the reduced note? We've had some good turnouts on the shows. New equipment, yes, I'm going over there probably later in June to install this new shutter on the Canary 2 CCD camera. We've also got the new seeing monitor that's being installed, and I'll be doing some general tidy up work. There's a good possibility that we'll also be installing a second solar telescope, which will give us a complementary view to the existing. So the existing view won't change, but the new one might give us a full disk view of the sun so that we always get to see the whole disk and we always get to see the other. It also means that we can tune one to surface details and one to prominences and stuff like that if we want to. So Carol's asking a question here. When reserving an object by catalogue number, we have the obvious choices of open cluster, faint nebula, etc., with different filters applied automatically to the various choices. How do these filters enhance the overall result, and when would one choose generic or multi-luminance? Well, if you're just going for any old object, you don't really know how bright it is, you don't really know very much about it, then generic's the one. But you're right, if it's an open cluster, then choose the open cluster, because that processing preset is what they're called. It's the instructions that we send to the telescope to gather up all of your images and data, and then how it processes them. That's Slooh's patented technology. It's tuned for particular objects. So faint nebula is another good one. But we have introduced this new one that I'm working on at the moment, which is specifically for planetary nebula. So that's going to be quite an obvious one as well. Faint galaxy, large bright nebula, stuff like that. A lot of those are fairly obvious as well. But, you know, when a lot of people do ask me about this, I say experiment. You know, they ask the question, you know, at what magnitude for a particular galaxy do I choose the faint galaxy or comet versus the bright galaxy or comet? There are so many things that can vary in that equation that I always say experiment. I mean, first of all, an object's brightness, a galaxy's magnitude, its apparent brightness, is measured over its entire area, so it can be quite a high number if it's a very large galaxy, but it might be quite diffuse and faint. So try it out. But there's one there that you have mentioned there, Carol, which is called multiluminance. And there are two of these processing recipes. There's a multiluminance 20 seconds and there's a multiluminance 50 seconds. For one of the telescopes, it's multiluminance 60 seconds. And what this is doing is this is for people who are doing one of two things generally. One is it's very popular for the near-Earth asteroid and the comet hunters. So the A-team group who track asteroids and comets. They're not really interested in seeing those objects in color. And the color filters that we use for our grayscale CCD cameras actually reduce the amount of light that's getting through. They want to capture as much light as possible. So they're really using this luminance filter, which looks clear, but it's actually not clear. It does block some wavelengths of light. But what that does is it just takes the multiluminance recipes, processing presets, take a whole series of images through that same filter. And then those guys who are doing a bit of science might be doing some astrometry, which is measuring the position of an asteroid or comet. And the other group who use this are the guys that you see who are doing image processing of their own. And that's, I think I said this during last week's live cast, the detail in an astronomical image comes from the luminance data, the luminance images. The color images, the ones taken through the red, green, and blue filters, they kind of give a color wash. They don't really add any detail to the images. So a lot of the astrophotographers that you're seeing build up a big set of luminance data using the multi-luminance processing options, and then just a smaller set of color data to just kind of color wash over the top. So Carol, I hope that answers that. Yep, you saw my interesting night of planetary nebula when I was testing those. David H. Oh, David H. was saying he's still collecting for his Messier poster from the Messier Marathon, and I couldn't help but share one of my favorite images because people were talking about printing these off and putting them on their walls and stuff. That's from David Malik of Comet C 2014 Q2 Lovejoy. That was a splendid comet. We watched these dust trails in its tail changing from one mission to another. There's an animation somewhere as well, which is pretty cool. But anyway, any other questions in these last little bits? Such fun. Really enjoy the mechanics involved. Yeah, I do as well, Stephen. I know you keep an eye on a lot of planetary phenomena, and I love all of these things that kind of demonstrate to us visually real objects, not just graphics or NASA animations, but these real things, you know, like we've done tonight, that display and illustrate these celestial mechanics of the heavens in action. And we kind of get it from the Slooh Solar Telescope as we see those features, you know, revolving as the sun spins on x-axis. We've been watching the moon's libration tonight. And of course, we see the moons of Jupiter as well, which is always a great one. There's 185 known moons in our solar system, Stephen's saying. So it's going to be interesting to see how many we can capture. Well, don't think there's going to be quite that many, but I reckon, you know, if we all pull together on this, we could do pretty darn well, especially if we got people like Jay kind of helping us with Mars's moon Deimos, that really difficult one to capture. A bit of talk about how we can chat during shows. Michael T's asking, is there a quick way to list the details of all my reservations? Yes, there was. Michael's sorted it out, but I'll show you if you come here to settings, dashboard. This will show you a list of all of your upcoming missions. All right, so this is also, there was another question during the week, where can I cancel a mission? And you can cancel it in here if nobody else has piggybacked on it. But this is where you can see a list of all of your missions. So that was settings and up to dashboard. But Michael actually found that. So GL is asking here, how about some discussion on the differences between FITS versus the PNG data? What data is only available to apprentice and astronomer members? So you may have heard this thing mentioned on the website called FITS data. FITS data is just an image format that comes out of an astronomical CCD camera. So it's just a file format, if you like. We then put our patented technology to work on that raw FITS data to produce the real-time grayscale and color images that are then delivered to the telescope pages and to your My Pictures area. And we use PNGs for that. So PNGs are just a really good image format. You know, so all of these moon images, these are all PNGs straight from the telescopes there. The only reason why you really want FITS data is really those two groups of people that I've already said. People doing science need the raw FITS data to perform their astrometrical and photometric measurements on, but also those people wanting to do some image processing can also use the FITS data. But there's actually quite a lot of data that, a lot of processing and improvements you can do just using the PNG data, that the PNG images that you can do as well. So, but well, as Slooh crew, you only get PNG. Only astronomer members. This might be changing. Only astronomer members have FITS data. Might have changed recently. I need to check on that. If you want to try image processing, how can I get the FITS or raw data? Upgrade to astronomer, Michael. Sorry. No easy question, no easy answer on that one for you, I'm afraid, but my goodness, it's cheap to do so. So you can upgrade very easily as well. Michael T again is saying, wanted to cancel. Okay, so he's found all those, so that was the post above. Oh dear, James B was getting a bad audio echo. Oh dear, I hope not. Did anybody else? Audio is smooth down here. And, right, okay, James B, I suspect I know what you've done. You might have two windows, two tabs open with the Slooh website. So if you've got one open, it might be playing the audio player. If you've got the sit room, they might be slightly out of sync, which is why you'd be receiving two lots of audio. So Carol B, good show, thanks. Audio down here in South Africa, good, smooth down here. Thank you very much. You can have a like for that. That is it for me. Don't forget our show Tuesday night, the same time as this started, 7 p.m. Eastern. And don't forget Helen Avery's show a little bit later on tonight as well. That's all from me, Paul Cox, here tonight on Practical Astronomy. I'll see you again next week, but I'll see you on Tuesday first for our full flower moon show. Good night, all.